I personally have few problems in getting up early in the morning because my kids always get up early, even on weekend, and I'm usually awake at 6. But getting up at 3:30, for example, is a different thing. So that nobody is amused from us if we need to do that. And if a container is crashing or cluster crashing or whatever, I mean, we would like to go to bed as soon as possible, and what we want is kind of understand what's going on and be right on the right KPIs in front of us, see what's wrong, and not have to search and bring logs and matrices and traces together for a few hours to understand what's going on here. So we want to be on the root cause in 5 minutes and fix the problem and go back to bed, even if probably our sleep is not good anymore then, but that's the aim to achieve. So in the event of malfunction, the correct operating and monitoring data is needed directly in order to quickly draw the right conclusion to solve the problem and go on. And this is usually quite a challenge, especially if it comes to containers or to microservice and application with multiple different modules who are connected somehow together. And this journey can be pretty dangerous. With all the advantages it can be pretty dangerous, especially if something goes wrong and the ship, like here, sways. We lose a few containers. And the question here is, how can we do the best job for our customers? How can we best equip ourselves to deal with disruptions like this? Effectively deal with that, and how can we tackle the challenges in the best possible way, and of course how can we go to bed as soon as possible again. And let's zoom a bit out, to have a general view. So let's talk about overall observability at AWS. We generally bucket ourselves into two basic categories. We have on the left-hand side the native services coming from the CloudWatch ecosystem. There are metrics, logs, traces there, container insights, application insights, all brought together in CloudWatch Service Lens. And it's fully integrated within the suite and covers all your different telemetry signals and so in one place. There are also other modules which you can connect there, like a contributor insight, which analyzes time series data, bring them together, that you have everything in a time series and not need to find the logs and the traces and kind of look at which second what happened. So that comes all together there. You have synthetics, where you can have kind of an outside view, have canaries installed or something like that, which gives you the customer view, making requests on the API or on the web front end or whatever to kind of see what's going on from a customer perspective. You can also bring those metrics in or those. We have RAM, which is a performance monitoring for web services, where you can see what's going on the web service, what requests are coming, how long they take to give an answer, and so on, and also something similar with Internet Monitor. And on the right side, we have for customers who are more on the open source strategy, they can choose the service on the right-hand side. They have more, let's say, open source, but still managed by us, by AWS services, like Managed Grafana, like Managed Prometheus, as well as Amazon OpenSearch service. Managed, I come to that, what that means. It's a bit more in detail on the next slide, like here. With Managed, one thing which is important there is security. So we offer a secure way to integrate AWS Identity Access Management in this thing. So it's integrated in that for authentication, authorization, so who is able to see what. We ensure that all your data is encrypted at transit and at rest. So the encryption is given. Security is also included in patching, like we do the security patching for those, for Grafana, for Prometheus, and so on. So you don't need to to do that, we also do the scaling. If you need more resources, we scale that. We make sure it's deployed in different availability zones, so that's high available. So all these things are managed by AWS, and you just have to consume the service and pay per use. And even if you scale, the service scale with you, you don't have to over provision resources in front or do those kind of things. That's actually the thing, that's the one with over provisioning, production workload. So we make sure it's in different availability zone and so on. We provision and integrate with several AWS services, included the builder tools like Cloud Formation or CDK and so on. So you can also use it integrated with when you use CDK, for example, or with CloudTrail auditing and so on. And of course, we also contribute back to the open source community. So we are in close relationship with them. Actually, we are part of them. And so if customer says to us, hey, we want to have new features in this managed Grafana or managed Prometheus or whatever, so we take that, we make a feature request back to the community, or we do it ourselves and contribute to the open source community that way. So that's kind of fully integrated and work together. So it's open source service, but still managed in a low level. So you really don't have to care about the basic and can just consume it with all the feature. You can also add the add-ons. I think for Grafana there are about 400 add-ons which you can use for if you like them. So that's kind of open platform. Challenges, when we come now a bit more to container, what are challenges in container environment? We see classical problem you often face with container observability. So from onboarding barriers to actually enable container observability, to figuring out what metrics you need to collect. So what is important, what is not important, to not distract you from really going to the root cause very fast. To understand what impact what impact it is when something goes wrong, and to understand how you get to the right opinionated best practice, and to have those in place so that everybody in your organization knows what metrics to collect and what the metrics meaning is and how to analyze them and how to react on them. So that's probably the most important thing. And of course, the weight, the cost, regarding or in relative to the value it gives. So again, make sure you monitor and collect the right things so that you don't have overcost and things which you never need. But still, you need a lot of things. Probably you get the root cause, but kind of leveraging that is a bit of a challenge sometimes. Application can be complex. So we talked about microservices before, container and so on. So we have a lot of different modules connecting to each other, have interfaces. Maybe the database is a central part where multiple containers connect to. So that could be pretty complex, and to find some root cause there is a challenge as well. But on the other side, I mean, distributed applications have real benefits like scalability. We can easily scalable then on modules. We don't have to kind of scale a whole monolith just for one part of the application. We can really scale what the module we need. And of course, we are more agile. We are more deploy them much easier, independent. Just need to make sure that the connection is working.
Ja, ist anders. Stumm, warum auch immer.
Sorry, I need a second. And where was I? We have the challenge to detect actually response or then find the root cause. Also because maybe we have some another challenge. We see we have some kind of siloed data. So customers have different responsibility. One is responsible for the database, another team is responsible and has the monitoring tools, another one is responsible for the cluster and prefers something else. And we have maybe 5, 6 different monitoring tools, 5, 6 different access sets, and bring that together to one view, to one correlated view, where log trace and everything comes together. It's sometimes a big challenge for in an organization thing, how we bring that together and kind of use one solution instead of 5. It's maybe a political thing. It's everyone goes with that what he prefers and knows, and all this let's say human-made problems or challenges. Benefits of application-centric observability. So now if we really go to an application level, is we understand the application health. We can improve the performance and the availability of the application, so the mean time to repair if you have the right data collected and brought together. We can reduce the operational costs because we are very fast and try to collect the right thing, and we are very fast in problem solving. And of course, with all that, I mean, a few more. I don't want to go too much in detail, but with all that together, we can at the end of the day improve the customer experience, and that's what we want to achieve here when we operate workload from container workload or whatever. So let me ask you a question here. How often you as a member of a central operational team or platform admin or team or whatever you are in end up with cases where you find cluster nodes, containers not monitored closely or have alarms on? Or maybe you have alarms on, but do you have cases where you feel like you need more information to understand how the application and the end user experience is affected in an error, or such as so that you can decide about the severity and the criticality and the priority to solve that? So do you have the visibility you use usually? I don't know. We see that often as a huge challenge, or customers are contacting us often, and how do you do that, and how we really have the right visibility and so that we can mitigate this as fast as possible. And so it's a challenge to not having access to the granular data you need, but not having the required alarm set to receive the notification or mitigate them proactively. And using aggregated alarms sometimes, so they are aggregated alarms which cause another alarm, but to drill down then and see what actually is the root cause it's pretty challenging and could take some time, and that's what we want to avoid here. So in customer conversation, we hear all the time that we need end-to-end visibility across all our applications. We need health dashboards. We need to identify the impact from the infrastructure failure on the application, and the application from the application to the end user experience. And so this ladder up and ladder down, kind of granularity thing. And again, it's all about impact. And let me take a sample here, what we need to achieve. I think the agenda says it gives pizza later. So when we order pizza, once we place the order online, you want to have the visibility on the whole life cycle of the delivery. So you want to know if it's prepared with the ingredients you ordered, if it's already in the oven, if it's already in the box, if it's in the car, and when it's in the car, where its location is. And so that you can make kind of your conclusion that you see if, okay, it's now more than 30 minutes out of the oven, but it's not out of my door. So we probably have an issue here. The customer experience is not the best anymore because my pizza is cold when it arrives. And I can already kind of prepare or go for the next steps. Whoa, like prepare my own oven to heat it up again and so on. So let me be quick. We need a kind of a shopping list for what we would like to have. So it's the volume of the requests we need to manage, the latency. We want to have some visibility about the latency for the application. We need to see the faults and the errors. And to address that, what is this we need, because we face some challenge with microsystem or with microservices, with all this application. And here we have the microservice architecture. We have often a lack of standard application metrics, so we don't just can pull standards. We have difficulty to prioritize the business goals, and for that we have brought together this in the application signaling service, or in this whole suite of CloudWatch, which I showed before. So there's included a discovery service. We have standard application metrics included there. We have service level objectives where you can, the business requirement, you can kind of mirror them in the monitoring and alarm against them. So you really see what is important, what needs to be monitored, and we can really quick come to the root cause in a few minutes. Application signal, what it is, it's a service dashboard. It creates itself a service map, so it correlates. It says, okay, there are the connections in between. It correlates the map itself. It has the service level objective dashboard where you can see, okay, there are the real measurement we need to do, and we can alarm against that. And you can enrich that with the synthetics, with the canaries, with the real user monitoring and the resource monitoring, of course. Bring that all together on a timeline. And I skip how it works in detail, but it collects telemetry. As I said, it discovers the service, troubleshooting with metrics and traces, set the SLOs, and then enrich that with synthetics and so on. So we enriched it with quite a lot of features at reInvent last year in December. So one of the most important thing is probably Amazon Q Developer. So we connected with that. Amazon Q Developer can now analyze your logs, your trace, your map, all what's coming in, and see, okay, there's a fault, and suggest already a solution before you get into and dive into and need to spend 2 hours for a root cause. So it does part of the work for you. And propose a solution. So let me quick play this demo. I wanted to show you how that works. So to access container insights from a CloudWatch console, all you need to do is to click on the container insights. So this is the container insights landing page where we provide you with the overall view of the performance across your whole cluster base and the whole container base. So here we see we have 13 alarms configured, and 2 of them are actually under alarm. We see here the colored ones, the colored 6 sticks or whatever are. So there are the cluster who run on a certain level of load with CPU or RAM. So we can dive in proactively and see, okay, are there the next problems one maybe or not? On the right side, we see actually this has the ability to go cross-account, so it can see your whole organization, all the clusters, all the pods, all the thing, and kind of summarize that. So we have really one centered view. You don't have to do that in each account. You have a holistic view on the whole organization. And so that's the cross-account listing. And yeah, here you see just the nodes which are the ones with the highest load, which achieve my bar here or goes over the bar, actually alarming. And if I press on an alarm, I get into the detail page, and there I see everything from the cluster down to the container. I hope that comes in a minute. Sorry, it's a video which. So now if I click in the detail hereof, I see on the left side everything from container to from cluster down to a container, so I can really dive in the level I need very quick. And this shows here then the details from the CPU, for example, from the cluster, and we see that it goes over the limit of my 80%. But we don't know at this time the reason for that. So we need to dive a bit deeper. Oh, sorry. Actually, have I a minute more? Let me go a bit further. So we can dive here in more details, and actually the important thing when we come down to AppSignal, we see here then in more detail what's going on in the application. So we see an increase of the requests, so that the volume increases, and that causes the CPU to generate more loads. So here is the, I skipped a few things, but here we are really on the application level. See what's going on inside the application, and we can also dive further in to see more details. Can trace some things we see here. The correlation it automatically has created for us. So we see the web service who has the highest CPU load, but that caused because the front end, the clinic front end has the high amount of requests, which we have seen before. So we see the correlation of those two. And going a bit further, we see all the details, what's going on application level, how milliseconds, which requests, uses, and we see which are on alerts, because we have a threshold on 21 milliseconds or seconds here, and that's alerting then for and if we go further, we can even go in the module and see even in more detail. So it has already predefined the request. I can just run the request, and I see really on a time basis the logs, the metrics, everything collected together in every detail, and can there really be on the point very, very fast, because we have all the layers from infrastructure, from mid layer to the application level correlated together. With that, I want to stop. Thank you for attention, and if you have any questions, I'm here later for answering them.
So in theory, I have prepared a very similar demo to what you can.
Oh yes,
a very similar demo to what you did. Pets clinics all the way. Cool. Single pet clinic, right?
Right. Yeah.
So once my screen shows up, if ever, I would just, because I'm not going to repeat the demo you've just seen on the video. That doesn't make any sense. It's late enough. There's pizza. But what I would like to show you real quick is how quickly you can enable App Insights on a running Kubernetes cluster and a running EKS cluster, because it's basically 3 clicks. Of course, if you do it as a code, it's about 15 lines of code, so depends what you like.
Need to press.
You don't need to press again. Maybe I pressed too early. I tested it earlier today.
Change the port. Yes.
Let's try that again.
Ich kann nicht mal was drucken, mir ist
I
gerade
do
gekommen.
like HDMI cables.
And be patient. Be patient.
Oh, there we go. Woo, success. Cool. So what I prepared is basically 2 demos. Again, I'm not going to repeat them. One was Lambda based, because I do like Lambdas very much, and it's also very simple to enable App Insights in Lambdas. It's basically 2 Lambda layers you need to attach to a Lambda and match it. Of course, there's more than magic, but it feels like magic. So what I would like to do is just really quickly, in the next 2 minutes, show you how to enable App Insights on Kubernetes. So to do that, I should have a Kubernetes running somewhere. Yes, I do. Fancy. So once you have a Kubernetes cluster, there's 3 things you need to do. First, you need to install the CloudWatch Observability add-on. This add-on is not installed by default, even if you run EKS Auto. EKS Auto manages your whole Kubernetes cluster automatically for you, which we use by default. Really nice, less admin work, cool. But you need to install this observability add-on. This is 1 click here, or about 5 lines of Terraform code, depends on how you want to deploy that. Once you have done that, you need to do 2 more things, 3 more things. Your Kubernetes cluster nodes needs to have X-ray permissions and CloudWatch agent server policy attached. Those 2 policies allow your EKS nodes or any pod that runs on those nodes to provide your traces, your metrics, and your logs. I don't know what is the default in EKS Auto. We always create our own custom policy, but it's possible that they even may already be there. I manually add them. The third thing you need to do, and the AWS console does that automatically for you when you open the App Insights the first time. As I do not like magic, I created my own custom so-called service-linked role, which allows the application signals to communicate to CloudWatch. And then basically the base setup is done. And now for the magic. I have running my little beautiful pets clinic service. If I go to my pet clinic, that should load. Hello, pets. Hello. Yeah, I can click around, it just works. Now, of course, now it doesn't work because it's demo, so I'm running a very aggressive Aurora auto-scaling, and the Aurora database just shut down. So I need to restart my service, but that is good, so I can show you the SLO error reporting real quick. But now, this is a Java Spring Boot application which doesn't know anything about instrumentation. There is no code in there which does OpenTelemetry or Prometheus or whatever's. The only thing you then need to do in your Kubernetes or in your setup of your resource inside Kubernetes is you need to inject one annotation. I have done that on namespace level. You can do that on pod level or on deployment level. And this annotation, second page, this annotation is this one. Tell the system to inject the OpenTelemetry Java agent. So this means when your pod starts, the CloudWatch add-on, which we installed before, will automatically wrap your executable Java, Go, .NET, Python, maybe Node.js, I don't know, could be, automatically wrap your binary around OpenTelemetry around your binary and start exporting all your basic metrics. So basically what Michael said, the same defaults, right? We do not want to change anything, we just want to get started.
And it doesn't need any change in the application,
Yes,
so no code in the
application. Is this little key annotation here, which then injects the OpenTelemetry agent. I'm just going to need to restart my customer service because that thing just crashed. So we may see, you see, it's shut down. But you will see now, there we see those Amazon OpenTelemetry log lines. I don't know if you can read them well, but you see it's just automatically checked. This is not from the Spring Boot application. This is the CloudWatch Observability out on managing those. So by the way, now I should see my pets. Just a quick test. Yeah, look at that. If the database runs, the application works. Now, the cool thing is we will now see an SLO error if I refresh. So yeah. So this is now App Insights. The only thing I did, again, remember, I installed the add-on, I set up the roles, I injected the namespace annotation thingy, and already all of my services show up. So I have my customer service, I have my visit service, my API gateway, my vets. We can compare them real quick. API, customers, vets, visits, cool, that seems to have worked. I defined an SLO, a very aggressive one. If one request in 5 minutes fails, it sends an alert. So we have now an SLO level alert, not just on metrics, right? It's really just, hey, if my request, which I have defined here, fails in a rolling window, get me an alert. Doesn't matter what exactly happens in the background, the request was just not successful.